Thank you for joining us for today's online seminar. Today's topic is how to reduce vehicle noise with IGUS plain bearings. Your presenters today are Sebastian, our automotive sales manager located in Germany at our worldwide headquarters. In addition to that, we have myself. My name is Nicole, and I'm the iGlide product manager for IGUS Inc. in North America. And in addition, we have Sam Valentine joining us. He will be moderating today and answering any questions that you might have in the chat. Thank you for joining, and let's get started with a short video.
Hello and welcome everybody from Cologne in Germany to the US, to you. And I'm really excited for today's online seminar with the title, How to Reduce Vehicle Noise with IGUS Plain Bearings. So let's go over and jump directly into our agenda. First of all, we will take a short look into our company. What is IGUS? What are we doing? How were we founded? And which kind of products do we produce? And then we will directly go over into the topic about, is it possible, or how can we help you with our plain bearings to reduce noise in applications for automotive? Last but not least, as Nicole already mentioned, Q&A. Just please feel free, put your questions into the chatter. Sam will and the team will answer them right away. Speaking about the team, you can see here on the bottom right, we have specialists only responsible for the automotive industry. So service and support is always for us the most important point. So please never hesitate to contact us. We will always be here to help and support in each kind of technical, etc. topic. All right, then let's go over and check out a little bit about IGUS. Actually, our company is a family company, and you can see the founder, Mr. Günther Blase, here, and he is standing next to his wife, Margret Blase, in front of their private garage from back in the days. And this is where they founded our company. The idea he had was he went into an automotive supplier, a very famous one called Pierburg, and he asked one of the engineers, like, please give me one part you have some issues with, you have some headaches with, and I want to replace and improve your product. And finally, he could make it. He invested into an injection molding machine, studied about materials, and finally could replace the metal part into an injection molding piece. And what he achieved was a longer lifetime for the part, as well as lower part costs. And this is still our approach. We call it tech up, cost down. And this is everything what we still follow with our products. 13 years later, we went already in a little bit bigger building. You can see here some good looking cars here in front of the building. And nowadays we are really happy with our headquarters here in Cologne in Germany, as well as our very nice looking building in the US. Speaking about products, on the left side, you can see our department and division about energy chains and rack chains, as well as our harness or cables, and also our pre-harnessed solutions, always with the focus about saving costs in assembly times. On the right side, you can see our bearing department. Here we are offering nearly each kind of bearings, like the linear bearings, spherical bearings, or the standard sliding bearings in each kind of geometry, sizes and designs. And this is what we will focus on today about the sliding bearings. Let's raise the question. Is it possible, or how is it possible, to reduce noise in vehicles with IGUS bearings? Before going ahead, let's take a look into the topic noise. So why is noise one of the most essential requirements nowadays? There are a couple of reasons. For example, for the combustion engines, we are getting more and better, higher quality insulation. For the electrical or the hybrid vehicles, they run very quietly. They don't have any engine noise at all. And that means there are not so many noises which can cover an additional noise coming from the applications. Another point is the safety factor. Like if you imagine driving on the road and you hear while pressing the pedal always like a squeaking or rattling noise, this can irritate the driver and also like reduce the concentration. Another big point is the high quality impression, the feeling. Like if I'm going to a car shop and trying to check out a new car, sit down in a very fresh car, put my arm on the armrest and directly hear a squeaking or rattling noise, I will decide within seconds to not buy the car. And in the real world, this is a condition, and this is why the noise management is definitely one of the biggest targets and the focus of many of the engineers. Talking about some phrases, for example, BSR is a typical phrase for noise description like buzz, squeak, and rattle, or the short form NVH means noise, vibration, and harshness. These two phrases are very well known and always focusing on all the noises and describing all noises which are generated by the assemblies or by the components in the vehicle. For sure, it's getting tested in all kind of noise chambers or during test drives. The next point is, or let's check out how the noise can come from the bearing, and we divided this into three parts. Like the first reason to have noise from the sliding bearing or from the bearing at all can be the lack of lubrication. The second point can be the wear, like worn out sliding surfaces. And the third point, Nicole will take over and concentrate on the system play, like the clearance behavior between the shaft, the housing, and for sure the bearing. And now we will take a look into each of these 3 points and how we can help to reduce the noise. So the first point was lack of lubrication. For that, we have to go and think about the first slide about the product. So what do? We produce products which are always made for motion applications. In the automotive department, it's, for example, for the pedal, the oscillating bearing position while pressing or activating the pedal box. It can be a throttle valve, or it can be even a water or a coolant pump with several thousand RPMs. And for these high demanding applications, you need materials or products which are also capable to take the high speeds and the wear requirements. For that, we are really into engineering. We focus on, we call it tribopolymers. Like all we do is injection molding and developing special compound materials to fit into every individual application. What do we use for it? What is in our material? The basis is always a thermoplastic. Like here we are using all kind of thermoplastics from the market, PS6, PS66, up to PBT, PPS, or even PEEK we are using. Then we are adding reinforcements like this one to make the material stronger, to make it more capable to carry more load and shock loads, etc. And now we come to the big secret and to the point of this slide, because the last ingredient is always dry and solid lubricants. And you can see it here. We are mixing, blending, and compounding the material. And that means you have dry lubricants all over the wall thickness inside of the material. And that means you don't need any additional lubrication, and you can use our sliding bearings fully dry, and you don't have the risk about gone or taken out lubrication. That means no noise can come over the lifetime. We always have lubrication inside the applications. The second point is about wear. So here we concentrate on the comparison of a metal polymer compound bearing, a very commonly used bearing from the market with our IGUS tribopolymers. So starting on the left side, this is the typical design. Usually you have a steel back. If we check it here in more detail, like the steel back is the main proportion of the bearing out of metal. Then we have some bronze layer, and finally on the real running surface we have like a PTFE or a Teflon layer, and this is typically very, very thin, like we are speaking about 50 microns in average. If we think about the last slide and what we are developing, we always focus on homogeneous wall thicknesses. That means we find not only a thin sliding surface, we always have the same components, the same ingredients, let me say, inside of the material over the, not only on the surface, also if you are inside of the application. And let's compare what is happening if we are running inside the application. For the metal polymer compound, we made like a simple sketch here. So the thin PTFE layer, which is there, which is relevant for the for the sliding surface, is very thin. So once you have a little bit of misalignment of the shaft, for example, this can be easily damaged. Or if you run over the lifetime, this can be worn out, and then you are not touching any sliding material anymore because you get in contact with bronze and with steel. This can definitely cause a lot of scratch marks on the shaft, which is then a metal-metal contact, means the metal from the bearing is in direct contact with the metal of the shaft, and we can all imagine that this can create a lot of noise. Comparing with our material, you can see that the solid lubricants are over the whole wall thickness in this sketch here, and the shaft will look clean and without any scratch marks over the lifetime. We don't create any noise even after some wear is happening or some misalignment is destroying and damaging the surface. All right, these are the first 2 points, and now I'm really excited to hand over to Nicole for the third big topic here. Thank you very much for listening so far.
Thank you, Sebastian. So Sebastian already talked about lack of lubrication and wear and how it can impact noise in automotive applications. Now we're going to take a little bit of a look at initial system play. So basically the play between the bearing and its mating components. This is a major culprit for increased noise. We have a couple of options here, and we're going to talk about both design and process considerations for solutions in this area. So something that we've done previously for axial tolerance compensation or absorption, you can see there's a little feature under the flange right there, and that allows for absorption of any type of play or allowing for reduction in system play. In addition to that, we have customers quite often who have larger housing bore tolerances, and this can be complicated, and it can mean that you'll have quite a bit of play between both the mating components and the bearing itself. So we can solve that with compensation using linear ribs. And what those linear ribs do is as you press the bearing into the larger housing, if it's not perfectly round, the bearings that are in the portion that might be a little bit larger will stay to avoid any rattle between the bearing and the housing, and the other ones will kind of compress down. So they'll be flexible enough to compress down, and therefore you'll have a bearing that will reduce play significantly. So those are 2 quick options. We have another option for design that we've talked about previously, and we'll get into that now. So in this case, we have, you can see a coupling joint, so basically a ball and socket joint. And our standard product here, you can see we offer quite a few linkages for all different types of applications. And you can see on the left-hand side, our ball and socket joint. The standard design has a rather large void between the metal ball and the socket itself. And what we did is we changed it to a different material for a little bit more flexibility, and we did a raised undercut. And what the raised undercut did was eliminate any option for dirt or debris to get into the bearing point. So dirt and debris can then add excessive wear, so kind of going back to Sebastian's point, but they can also increase noise quite a bit. So in this case, we've reduced the amount of noise that gets into the bearing system, therefore reducing the amount of noise that is located there. So next up, we're going to talk about applications that we've solved with iGlide bearings in the past, so automotive applications, and for the purposes of this webinar, we're talking about noise. So noise-sensitive applications, if we were to look at those, then let's take a look at the noise-sensitive applications. You can see it's pretty much everything. So for today's webinar, we are going to talk specifically about pedal systems, steering systems, as well as seating and hinge applications. Now, that doesn't mean that ideas won't come for some of these other applications or areas based on designs or other concerns. These are just the ones that we'll be focusing on. Okay, so if we're looking first at our pedal box application, one of the ways that we've solved this was through design is using our preloaded bearings. So our preloaded bearings are standard catalog offering. And what you can see here is if we were to take a look at the sleeve bearing on the right-hand side, it's a barrel-shaped bearing. So what it does when you press that into a housing is it compresses those little fingers at the end that you see onto the shaft, giving you radial clearance reduction. So minimizing the amount of clearance between the bearing and the shaft itself, or the bearing and the rivet. If you were to look at the flange bearing, this is offering you a little bit of radial clearance reduction as well as axial clearance reduction. So if you take a look at the flange, you can see that it is flexible and it looks a little bit pliable, and that's in order to absorb some of that clearance between the shaft and, the mating components, so where the bearing is fitting into. So completely reducing or eliminating the amount of clearance between them is key and ideal solution and easy, quick design fix for us. We have another application here that you can see. This is a steering system. And if we were to look at the picture on the right, you can see any amount of additional play would be significant in this application. So there's a lot of bearing points. It's actually quite a long system. So adding up any type of play between all these different areas could cause some issues. So this particular customer, this was a large OEM that came to us, and they were looking specifically at the support bracket. So they were using a simple plastic here, and they were having quite a bit of buzz, squeak, rattle, or BSR issues. This was giving them a lot of warranty claims, and they were facing a lot of costs just combating or talking about these warranty issues and claims. They came to us and were looking for a solution. What they required, of course, was something that offered a low coefficient of friction to eliminate the amount of stick slip, so avoid any type of squeaking in the application. But in addition, similar to what we just talked about, they were looking for a low clearance solution to avoid any rattle in the application and reduce the amount of system play. Of course, they wanted something that was easily assembled. This was an existing design, and they didn't want to take too many steps and have it be too complicated, as well as vibration dampening. So absorbing any type of shocks or shock loads to reduce the amount of noise there too. Looking for a wear-resistant bearing makes sense as well, because any amount of premature wear would then do exactly what we just talked about. It would increase the system play, therefore increasing the amount of noise. Of course, having something that was self-lubricating and lightweight was ideal as well. So in this case, we discussed using our preloaded bearing, the same bearing we just spoke about in the previous slide with the pedal system. And that's now pressed into the spherical ball. And the material itself offers an increase in lifetime as well as a reduction in wear. And then the preloaded effect reduces the amount of system play, therefore reducing the amount of noise. This then allowed the customer to completely reduce their costs for their warranty claims, and also made them feel a little bit more like as a good brand solution, good branding for them. So increase their brand value essentially. So this is a good example of reducing noise with kind of an easy solution, something that we've worked with quite a bit in our pre-tension bearings. So now we've talked a little bit about the design of the bearing itself, and now we're going to talk a little bit about process. So when we talk about seating or hinge applications, quite often we're talking about bearings that are used with sheet metal. So both in seating and hinges, we typically see customers using these sheet metal applications, which we usually use a clip solution. So our clip solutions are easy and fast assembly and allow for a great bearing surface here. That being said, we know that metal sheets or sheet metal housings can actually have very poor tolerances. So wherever the side that actually gets punched, you can actually see at the top there's quite a bit of a disruption and an amount of burr that's happening there. So at the bottom, you might see that the bearing has quite a bit of contact, and at the top, you see that there's quite a bit of system play possible here. Most of these customers are also using E-coating, and so we're going to talk in a second about how E-coating can actually help solve some of these issues. So E-coating is basically a process, I think most of you are familiar with it, but where the bearing, the component part actually is getting coated inside of a bath for coating or painting. And we're going to watch a video that I think explains this process really well and can explain how we can reduce the amount of system play using this process. So I think that video explains a lot, but let's just get into a little more detail on it. So if you remember, we talked about for sheet metal that usually there are very poor tolerances there. And so how can we solve it with using an iGlide bearing in combination with the E-coat process? So if you press an iGlide bearing in using a transition fit, and then you actually assemble a shaft or a rivet with an overlap fit. As the bearing's going through the E-coating process, there's a thermal recalibration that can then happen. And when that thermal recalibration happens, then effectively you eliminate the difference between. So if you look at that before and after picture, I think it's quite clear that before the E-coating process and the calibration process, you have quite a bit of area where it's actually a little bit difficult to see in that picture, but there's quite a bit of area that's not contact or not touching the completed surface. And after you're able to completely have a complete contact between the bearing and the components, therefore completely reducing the amount of play as well as the amount of rattle that you would get in the system. So just as a quick summary, when Sebastian went over lubrications, there's quite a few applications where lubrication is not ideal in applications. And we have for that, the solution, of course, is our iGlide bearings, which are all tribologically optimized using dry lubricants. So there's no need for external lubrication, and they're all self-lubricating throughout, also reducing the amount of friction in the system. And then we talked a little bit about wear, premature wear. So in the case of using a PTFE-lined metal back bearing, for example, it's a very small amount of bearing surface or sliding surface that you have with that PTFE lining before you have metal-on-metal contact. What that does is it increases the amount of wear, therefore increasing the system play that we talked about as well. So, an increase in wear then leads to more noise in the application. And then we talked a little bit about some of the design features that we can come up with. And certainly we're not limited to the ones that we talked about today. But just to give you an overview, we can talk about a little bit about design systems as well as the E-coating process. And we're happy to do that in more detail with you about your specific applications if you'd like. And finally, corrosion. So corrosion can be a concern as well. We didn't really touch on it too much, but any type of corrosion, the particles from the corroded material can get into the system, also allows for increase in wear on the shaft and the bearing itself. And in addition to that, the corrosion itself is then lending itself to an increase in play or clearance between the bearing and the shaft. So the solution is to use an iGlide bearing that's homogeneously blended and offers the completed wear surface throughout. It will reduce the noise in the application and actually be so quiet that even a baby can sleep while they're in the vehicle. And then finally, we do appreciate your time and attention today. We do want to let you know that we are happy to answer any questions that you might have, any suggestions, projects, bearing requirements. Also, we do offer virtual support. So if you'd like some of these webinars to be directed specifically for your customer, your company, we're happy to do that as well. We have a trade show booth in our Rhode Island facility that we can do a walkthrough and do a presentation specifically for your company as well. And if you have any questions, please feel free to reach out to the automotive team. And we have a couple exciting upcoming events. Next week, we have a live stream going on for IAA for commercial vehicles. That will be happening in our Cologne, Germany facility. We have a link for that Sam will be putting in this chat so that you can register for that if you'd like. It's actually at 10 o'clock Eastern Standard Time on Tuesday. September 22nd. In addition to that, Sebastian and I will be back on September 30th to do an online seminar for corrosion-free bearings in the automotive industry. So we look forward to having you join us for that as well. So look for the invitations. And we hope that this was useful for you. And we appreciate all of your time and attention.